Well, welcome everybody to the PostgreSQL Extension Mini Summit number 5. This week we have Yurii Rashkovskii of Omnigres, who comes with provocations for a universally buildable extensions, dev to prod. So Yurii, take it away when is convenient for you.
Sure. I don't think I can start the video. That's okay. I'm actually fine without a video.
Okay.
Yeah, that's good. So we can focus on the content. And let me share the screen. So yeah, today I'm going to be talking about universally buildable extensions, and this is going to be a shorter presentation, but the point of it is to create some ideas, perhaps some takeaways for some, and actually provoke a conversation during the call. So that would be really amazing to explore what others think. So without further ado, I'm with Omnigres, and at Omnigres, we're building a lot of extensions, and oftentimes the extensions that we make, they push the envelope of what extensions are supposed to do. For example, one of our first extensions is an HTTP server that is effectively embedding a web server inside of your Postgres. And so for that, we had to do a lot of things that are unconventional. And we have other extensions that are uniquely positioned to work both on developer machines and production machines because we serve the developers and DevOps kind of market. The point of Omnigres is turning Postgres into an application runtime or an application server. So for that reason, we really care about how extensions get adopted. So when we think about application developers, they need to be able to use extensions while they're developing, not just in production or on some remote server. They need those extensions to work on their machine. And the thing with that is not everybody is using Linux. Other people are using Mac OS, Windows, and we have to account for that. And there's a lot of interesting problems associated with things like dependencies. So there's a very common approach, often done by by those who try to orchestrate such setups and by some package managers, and that is operating out of container. And the idea here is that with a container, you can create a stable environment where you bring all the dependencies that your extension would need. And you don't have to deal with the sort of physical reality of the host machine, whether that's a developer's machine or a CI machine or a production machine. You always have the same environment, and that's definitely a very nice property of that. However, there are some interesting concerns that we have to be aware of when we operate out of a container. One is specifically mapping resources. So when you have a container, you have to map, how many cores are going there in memory if you're operating, say, Docker desktop. How do we map our volumes? How we connect networking? How do we pass environment variables? What that means is that whenever you're running your application, especially locally, especially in development, you're always interacting with that environment, and you have to set up for it. And this is particularly problematic with Docker desktop on, say, Mac OS on Windows, because these are not the same machines. You're operating out of a virtual machine instead of your host machine. And obviously, containers are Linux specific, so it's always Linux. And what we found so far that oftentimes it really makes a lot of sense to test extensions, especially those written in C, on multiple platforms, because in certain cases, bugs, especially critical memory-related bugs, don't show up on one platform, but often show up on the other, and that's a good way to catch pretty severe bugs. And there are also other interesting concerns that are much more rare, of course. So for example, you cannot access host GPU through Docker desktop on macOS or through Colima. So basically, if you're building something that could have been using the host GPU using some libraries that would work on that machine, that's just not possible. So if you're working on something ML related, that can be an impediment. And this also makes me personally wonder oftentimes, what are other reasons why we're using containers? One reason that struck out very prominently was that Postgres always have compile time paths embedded during compile time. And so that makes it very difficult to ship extensions universally across different installations, different distributions. And I wonder if that is one of the bigger reasons why we want to ship Postgres as a Docker container, so that we always have the same path regardless of where it's running. So, that was just like, for some reason. Any questions so far about Docker containers? I also, obviously, if there's anybody on the call who is operating a Docker container type of setup, especially in their development environment, if you have any thoughts, and if you have anything to share, what are the primary reasons for you to use Docker container in your development environment?
Probably similarity with the deployments, the production deployment environments is one.
Mm-hmm.
Being free from whatever is installed on your laptop, because maybe I don't feel like upgrading the system Python version and potentially breaking the entire Ubuntu. Mm-hmm. Whereas in a Docker container can have whatever version of Python, whatever version of Node.js, or mm-hmm. whatever other invasive type of service. Mm-hmm. So I guess these are good reason. Those are at least the motivation that brought me to start developing directly into Docker instead of using the desktop.
Mm-hmm. Mm-hmm. And do you find isolation, especially when you go all the way to production, do you find say container isolation? Of course, it's not absolutely foolproof, but the isolation of containers, is it something that was useful to you?
Yeah, I would say so. I think the problem is more to break isolation when you are developing. Mm-hmm. So just use your editor in your desktop and reload the code, having a direct feedback into the container. Mm-hmm. So I guess you have to break one barrier or two to get there. Mm-hmm. So mounting volume, etc. Mm-hmm. But I would say, at least from the privilege points of having Linux on desktop, mm-hmm. There is let's say a smoother path, because it's not so radically different being in the container outside the container. Mm-hmm. Maybe for Windows developers, and I don't know in what measure for macOS developers, it would be a different experience. Mm-hmm.
Yeah, I actually wanted to just drill down a little bit on this. In my particular experience, I built a lot on macOS, and there are, like you said, that you have to break through this isolation layers with the with the container itself, and obviously the VM that is there. And I found that there's oftentimes subtle problems that make the experience way less straightforward. So one example is, I found that in certain cases, you're trying to say map certain ports into the container, and you already have something, like, let's say Postgres running on your host machine. And depending on how you actually map the port, whether you specify or don't specify the address to bind on, you might not get Docker to complain that this port is actually overridden. So it can be very frustrating to find where is my port, because I'm trying to connect to it, but it's not connecting to the right port. So there's just very small, intricate details like this. And sometimes I've experienced problems like files are essentially not perfectly synchronizing into the VM. Although that has gotten a little better in the past maybe 2-3 years, but before there were definitely some issues. And that's particularly important for the workflows that we're doing at Omnigres, where you're running this entire system, not just the database, but everything that belongs to your web layer and whatnot, your backend essentially. And so to be able to reload, to be able to connect to what's running inside of the container is paramount to the experience.
Can I ask a question about the setup you're describing?
Yeah.
When you go towards production, are those containers designed to be orchestrated by Kubernetes, or is there different environments where you have your Docker containers in a local network, assume, so different Dockers sort of microservice talking to each other? Are you agnostic from what will run it, or are you run it on Kubernetes or on Docker Compose or some other form of glue that you set up yourself, your company has set up?
Right. So some of our users are using Docker Compose, to essentially put everything to run together. So that's how they use it. However, like I personally, when I'm working on this, I actually don't use Docker containers, and this is part of the reason why the topic of this presentation is I'll get to some details later. Is about universally buildable extensions. So I try to make sure that all the extensions are easily compilable and easily distributable on any given supported platform. But like I said, users do use Docker Compose, so that's quite common. I'm wondering if anybody else on this webinar has their preference or experience how they move Docker containers into the production or CI environment. Nobody. I'll move on then. So I wanted to show just a little bit of a proof of concept tool that we've been working on and off last year.
Yurii?
Yep.
There were a couple of comments and questions in chat.
Yep.
I don't know if you saw that.
Oh, I didn't see that. Sorry. It was folded down. Okay, Steven's saying something. Okay.
And Jeremy was asking about containers and platforms.
Okay, right. And so Jeremy is saying, when you say it's important to test on multiple platforms, do you mean in containers on multiple platforms or directly on them? In that particular instance, I meant on multiple platforms, so directly on them. And the other message from Jeremy was, I'm curious if you found issues, for example, with a container on Mac or Windows that you wouldn't have found with just container on Linux. So yeah, I did see some issues, basically depending on the on the type of memory-related bug. Basically, depending on the system allocator, I was either hitting a problem or not. And so I was not hitting it on Linux, I believe, and I was hitting on macOS. I don't remember details, unfortunately, right now. But that difference basically was indicative of a bug. And then Stephen wrote, trying to connect this. Have seen chip specific optimizations for containers. Okay, in Docker will run under emulation, but on Linux will run with real hardware. Yeah, that's an interesting one about AVX 512. So I suppose this relates to the commentary about GPU support, but this is obviously the other part of it of supporting specific hardware that is chip-specific optimizations. So that's actually an interesting thing to learn. I was not aware of that. So thank you, Stephen. Let's move on. So Postgres.pm, it's a proof of concept that I was working on for some time. And the idea behind it was both ambitious, but also kind of simple. The idea was, can we try describing Postgres extensions in such a way that they will be almost magically built on any supported platform? And the idea was to build essentially an expert system of how to build things from a higher level definition. So here's an example for pgvector. And it's really tiny. There's only two important things there. One is git tagged revision package and git repo. There's nothing else that describes package otherwise. And so the way this works is by inferring as much information as possible from what's available. Because it's specified as git tagged revision package, it knows that using the git repo that is specified there, it can go there and download the list of the version shaped revisions, and those will be the versions, and it can check out the code and do further inferences. And what it does there is, first of all, it infers metadata from meta.json if it's available. So it will know the name of the package, it will know the description, authors, license, everything else that is included there. It automatically infers the build system. So for example, for C extensions, if it sees that there's a make file and C files, it infers that you need make and C compiler, and it tries to find those on the system. It will try to find CC, GCC, CLang, basically all kinds of things. And here's a slightly more involved example. That's for PG curl. And there are two things here. Yeah, David saying, feel free to raise hands with questions.
Yeah, that was a question for David Johnson there too.
Okay. So David said, PG itself has installed check to verify that installed instance is function. What are the conventions methods that extension authors are using so that deployed container can be tested at a low level of operation for the installed extension prior to releasing the image to production? I guess the question is about general conventions for how extension authors ensure that the extensions work. But I suppose maybe part of this question is whether that's also testable in a production environment. David, are you talking about the development environment alone, or both?
Basically, the pre-release to production. So you go in there in development and you cut up an extension and source, and then you build your image where you basically compile it. In theory, you compile it into, you compile PG, you compile it, or you deploy packages, whatever. But now you have an image, but you never actually tested that image. And I can run install check on an installed instance of Postgres and know that it's functioning. But it won't test my extension. So if I install PostGIS, how do I test generically that PostGIS has been properly installed into my database prior to releasing that image into production?
So to my knowledge, there's no absolutely universal method. And of course, the PGXS methods are the most standard ones, like install check to run the tests. In our particular case, the way we do this, we replaced PG regress with PGY regress. It's another tool that we've developed, and it just allows for more structural tests and tests that are able to test certain things that PG regress cannot test because of the way it operates. I can actually share more about this later on the call if that's of interest to anybody. So we basically always run PGY regress on our extensions, and what it does, it basically creates a new instance of Postgres, unless told to use a pre-existing instance of Postgres, and it runs all the tests there as a client. So basically deploys the extension and runs the set of tests on it.
Okay.
Yeah. So, but I guess it depends on how you ship it. So, for example, if you look at the PGRX camp, they have their own tooling for that as well. And I've also seen extensions. At least I think all of them are open source, so can be found where they could be written in, say, Rust, but still using PG regress type of tests to test their behavior. And so that would often depend on how their build system is integrating those tests. So I guess the really short answer is there's probably no absolutely universal method. Yeah, David, thank you for paste and link to PGY regress. If there will be any questions about it, feel free to ask me. Any other thoughts, questions before I'll finish this slide? All right, I'll carry on then. So basically, the difference between this example and the previous one is that here it specifies that there will be an explicit revision map, because that particular project just does not happen to have version tags, so they have to be done manually. And you can see that in Git revision specification. But what's more interesting about this is that it specifies what kind of dependency it needs. So in this particular instance, it's libcurl, and the version has to match version 7, just any version 7. And so these kind of requirements, as well as compiler dependencies and make dependencies and others, are always solved by pluggable satisfiers. So they essentially look at what's available depending on the platform. Say if it's Linux and a particular flavor of Linux, if it's Mac OS, and picks the right tools to see what's available. And in the future, there's a plan to add things like building these dependencies automatically. But right now, it depends on the host system, but in a sort of multi-platform way. So the general idea behind this proof of concept is that we want to specify high-level requirements as to what we want, and not how exactly to accomplish that. So if you compare this to, say, a Docker file generally tells you exactly what to do step by step. So let's install, this package and that package. Let's copy files, and so it becomes a very specific set of instructions. There was a question: how does it detect that libcurl is required? So I'll go back to the previous slide. There is this line at the bottom, says requires external dependency libcurl. So that was the definition. And the other question was, how does it handle something with different names in different places? I'm not sure I understand this question.
I can be more specific on that. That would be if a dependency, I don't know, like libc, it's called libc on, where is it, on like Debian-based platforms, and it's called glibc on enterprise Linux places. And you can have some packages where the satisfier, you talked about available satisfiers like homebrew, apt, and package config, but what if it's a different name in homebrew than what the name is, in apt or something like that? Does it handle that, or is just that's not something you haven't tackled yet?
So it doesn't tackle this right now, but it's part of the division where it should go. Basically, for certain known libraries, there's an easy way to add essentially mapping. Say, if we're in this repository, the satisfier for that for that distribution will kick in. Otherwise, it will be a satisfier for another one. There are completely pluggable small satisfiers that are basically looking at all the predicates available to them that are essentially describing the system and underneath. Just for point of reference, for those who are familiar with this stack of technologies, and they may have seen that from the syntax. This is built on top of Prolog, so it's basically a system of like a knowledge base and rules how to apply this knowledge to particular requirements.
From your perspective, is that so? I think the follow-up question to that, I remember Devram talking about if you read through the spec files, what you end up with is all this like spaghetti code with these if-defs and all these logic branches. And in his case, it's just dealing with differences between Red Hat and SUSE. And is that, so if this is something that we manually put in, we kind of end up in a similar position where it's on us to create those mappings. It's on us to maintain those mappings over time. Like we kind of own it versus being able to like some kind of automatic resolution. I don't know if there is a good automatic way to do it. David had found something that he posted, which I looked at a little bit, but it is like Devram talked about how much of a kind of a maintenance overhead it becomes in the long run of just constantly having to maintain this, which seemed less than ideal.
It is less than ideal, and I like I said, for now, I do think that would have to be manual, which is less than ideal, but could be addressed at least on a case-by-case scenario, because we don't really have thousands of extensions yet in the ecosystem, maybe 1,000 total. I'm not sure. I think David Wheeler would know best, like from his observations, and I think he mentioned some numbers in his presentation a couple of weeks ago. But basically, handling this on a sort of case-by-case scenario, where, hey, we need this dependency, and apparently, it's different one on a different platform. So let's address that. But if there can be a method that can at least get us to a certain level of unambiguous resolution, automatically or semi-automatically, that would be really great.
I think there's a few more questions in the chat too.
Yeah. I'm just looking them up right now. How is the upcoming move to Amazon and core influencing or impacting this? I don't think it's really influencing this particular part in any way that I can think of right now, unless David, if you have thoughts how it can, I would love to learn.
No, I literally just started up a new machine yesterday and decided to build it from Meson instead of make, and the syntax of the Meson file seems similar to this. I was just curious if there's any influences there or if it just happenstance.
Well, from what I can think right now, there's just general reliance on either implicitly found pgconfig or explicitly specified pgconfig, and that's just how you discover Postgres itself, and there's no relation to how Postgres itself was built. The packaging system does not handle, say, building Postgres itself or providing it, so it's external to this proof of concept.
And that's a good separation of concerns, but there's also the idea that if core is doing something, we're going to build extensions against PostgreSQL. If we're doing things similar to how core is doing them, there's less of a learning curve and less of everyone doing their own thing, and you have 500 different ways of doing testing.
That's a good point. Something definitely to reflect on. I'll move on to the next question from Sean. What if there are no satisfiers for the install? If something isn't in your distro repo, how do you know where to find the dependency? And how is precedence handled? If two satisfiers will fulfill a requirement, will the highest version win? So if there are no satisfiers right now, it will just say, well, this is not solvable, essentially. So it will fail to do anything. So you would have to go and figure that out. As I said, it is a proof of concept. It's not meant to be absolutely feature complete, but rather an exploration of how we can describe the packages and their requirements.
I assume the idea is that as you come upon these, you would add more satisfiers.
Right. You basically just learn, like I was mentioning about other case-by-case scenario. We learn about this particular need in a particular extension. Okay, let's develop a satisfier around that. And the same applies to precedence. It's a question of further evolution. Right now, it just finds the whatever is available within the specified range, that is. If there are no more pressing questions, I'll move to the next slide.
Go for it.
So yeah, I was just mentioning the problem of highly specific recipes versus high-level requirements. Now I wanted to shift attention to another topic that was coming up once in a while in different conversations that I had, and that is whether to build your extension, and especially when you ship it, against minor versions of Postgres. And so for my knowledge so far, that different people have different stances on this, and even package managers kind of take different stances on this as well. So sometimes saying, well, we're just taking, let's say, a major version of like the latest major version of the of Postgres, and that will be the reference one. And others say, no, we'll actually build extension against every single minor version. And I wanted to actually research and see what's the real answer. Should we be building against minor versions or not? So I've done a little bit of experimentation, and my answer is perhaps, and maybe even test against different minor versions. So just from exploration of version 16, and I also done 15, I just didn't include it. There are multiple changes between minor versions that can potentially be dangerous. So one great example of that is when you have a new field in a structure that is available through a header file that is inserted in the middle. So that definitely changes the layout of the structure. And in this particular case, you, for example, will not get number of keys if you're intending to. And I think that change was from 16.0 to 16.1. So if you build against 16.0 and then try to run on 16.1, might not be great. The other concern that I found is there are new APIs appearing in header files between different versions. And some of them are actually implemented in header files, either as macros or static inline functions. So basically, when you're building against that particular version, you'll get the particular implementation embedded. And others are, just basically exports of symbols, like in this case, try index open and contain mutable functions after planning, if you're, of course, using any of this. But this means that these symbols are not available on some minor versions, and they're available later on, or vice versa. They may theoretically disappear. And there are also changes in inline behavior. So there was a change between, again, I believe 16.0 and 16.1, or maybe 16.2, where this algorithm has changed. So instead of just more than 0, there's now more or equals 0. And that means that particular behavior will be completely different between these implementations. And this is important because this is coming from a header file, not a source file. So you're embedding this into your extension. Yeah, it is a bug fix, but that means also if you build there was a message in the chat saying that looks like a bug fix, and it is, of course, a bug fix to the best of my understanding. But what I'm saying is, if you build your extension against, say, 16.0, which did not have this bug fixed, and then you deploy it on 16.1, then you still contain the bug because it's coming from the header file.
Yeah, but presumably they suggest that you build from the latest minor release, and that's backward compatible to the earlier releases.
Right, but yeah, and it's a good middle ground for this particular case. But of course, sometimes, like if you do a minor upgrade, you have to remember that you actually have to rebuild your extensions against that minor. So you can't just easily transfer them.
Yeah, when Jeremy points out that the struct change is pretty interesting.
Yeah, it's interesting because it's super dangerous. Like if there's, if somebody is expecting a differently versioned structure over here, then it can be pretty nasty.
Is that common? That I'm really surprised to see that in a minor version. But on the other hand, I don't know. On the other hand, I don't know that Postgres really makes promises about it. Some of this seems to come down to, like, when you're coding in C and you're coding directly against structures in Postgres. That's really interesting. I'm surprised to see that still.
Yeah, I mean, I didn't expect that either, because that's just a great way to have absolutely undefined behavior. Like if somebody forgot to rebuild their extension against a new minor, then this can be pretty terrible. But my general answer to all of this, unless you're going really deep into guts of Postgres, so unless you're doing something very, very deep in terms of, I don't know, query planning, query execution, you're probably okay, but who knows?
Well, but it's not just remembering to rebuild your extension. Let's suppose somebody is just downloading their extensions from the PGDG repo, because there's a bunch of them there. Like they're not compiling anything. They're they're downloading an RPM, and the extension might be in a different RPM from Postgres. And the extension RPMs, I don't know that there have been any cases with any of the extensions in PGDG so far where, you know, a particular extension RPM had to have compatibility information at that level, at the level of miners.
Yeah, so that's definitely a concern, you know, especially when it comes to not, you know, the scenario when you rebuild your extensions, but just get from pre-built packages. So definitely something, you know, it's kind of starting to leak out of the scope of this presentation alone, but I thought it's a very interesting topic to bring everybody's attention to. So yeah, basically, I think my last item here, going back to how we ship extensions and why do we need to have complex build systems and say packaging. So oftentimes you want your extensions to depend on some library, say OpenSSL or SQLite, whatever that is that you need to bring. And the default is basically to bring the shared dependency that would come from different packages on different systems. What we have found through our work with Omnigres is that it is increasingly simpler to either statically link with your dependencies, and of course you have to pay the price of larger libraries that you build, but then you have no questions about where would this come from what package, which version would that be. You know exactly which version that is and how it's getting built. So you have the right one. But of course, you also have a problem with if you want to change the version of the dependency, it's harder because it's a statically linked one. And so you can't really easily do that. The question is whether you should be doing that or not, depending on the authors of the extension and their promises for their compatibility with particular versions of their dependencies. So, but this one is kind of naive and simple, as in just, you know, use static. Sometimes it's not possible or very difficult to do so. Some libraries don't have build systems that are very amenable to static library production. So what we also found that works pretty nicely is using RPath in your dynamic libraries. So you can use special variables, $origin or @loader path. That's depending on whether you have Linux or Mac OS. And you can literally specify that your dependency is in the same folder or directory where your extension is. So you can actually ship your extension with the dependencies alongside. And so it will not try to load them immediately from your system, but rather from the same directory. And we find this pretty useful. So that's pretty much it. So just to recap, I was talking about the multi-platform experience and the pros and cons of containers, inferencing how you build and how you can build your extensions with dependencies, static and RPath dependencies, and the problems with PG minor version differences. So if anybody has any thoughts, questions, or comments, I think now would be a great time.
Thank you, Yurii. Already some good discussion. What else you all got?
I mean, PG basically, they don't do semantic versioning. We have a major version, we have a minor version. The minor versions are new releases. They do change behaviors. There's goals from the hackers to not break things to the extent possible. But yeah, they don't guarantee that this will not change between .3 and .4. When you're releasing once a year, that's not practical. If things are broken, you can't wait 9 months to fix some things. You need to fix them in the next update and backwards. So, yeah, we don't have a compatibility file, but we do have goals, and if they get broken, okay, there's either a reason for it or someone just missed it. From an extension standpoint, if you want to be absolutely safe but absolutely cost intensive, you want to update every minor release, compile, test, and do that. Depending on what your extension is, though, you can trade off some of that risk for cost savings. And that's just going to be a personal call. The systems that we build should be built around making it easy enough to do releases every dot and backpatching. And then, so they want to use it, it's easy enough. And then the real cost is, do you spend the time testing and coding against it to make sure that the stuff works? So our tool should assume releasing extensions on every minor release, not every major release, because that's the ideal.
Yeah, and that's exactly what I wanted, to bring to everybody's attention, because there's still a lot of conversations about this, and there was not enough clarity, I suppose, on that. So that helps a lot.
Did you say release or did you say build with every minor? I think I would use the word build.
Every minor release, so the ones that go out to the public. I mean, every commit you could update your extension if you wanted to, but really the ones that matter are the ones that go public. So when 16.4 comes out or .3 comes out, automation ideally would build your extension against it, run your test, and see if anything broke, and then deploy the new
rebuild
version
the extension
5 of your extension against version 16.3 of Postgres, and that would be your release.
Yeah, I mean, I don't think there's two things there. There's rebuilding it, because you can rebuild the same version of the extension, and that would pick up the struct. If they added a field in the middle of the struct, which is what happened between 16.0 and 16.1. And you could rebuild the same version versus you also, that the extension author, but what would they be doing? If they could tag a new version, but they're not actually changing any code. That doesn't actually, I don't think it is a new release of the extension, because you're not even changing anything in the extension. You're just running a new build. So it's just a rebuild. It reminds me of what Alvaro did in his OCI blog post, where he said you really have to, like, many of us don't understand how tightly coupled the extensions need to be to the database. And these C extensions that we're building are really, there are some risks here when we separate them out and we don't just build everything together.
So if you come across a point where, I mean, the change there would be metadata at that point. My version 4 of my extension, I know it works on 16.0 to 16.1. 16.2 broke it, so now that's where it ends, and my version 4.1 is known to work on 16.
But there is no difference between version 4 and version 4.1. It's just that you ran, in fact, there's a difference in the build artifact that your build farm spit out at the other end, but there's no difference in the extension.
Right. So if the extension still works, then your metadata would just say, not only do I work through version 16.2, I now work through 16.3.
But it goes back to the question, is the version referring to a build artifact, or is the version referring to like a version of the code? Which I guess I typically think of versions as talking about, as a user of something, a version is like the thing. It would kind of be like the code of the extension. This is interesting. Now we're getting all like meta here. I guess that there's arguments to be made both ways on that.
Yeah, other questions? Anybody familiar with the RPath stuff? That seems pretty interesting to me as a potential solution for actually bundling all the parts of an extension into a single directory, as opposed to what we have now, where it's scattered around 4 different directories.
Yeah, I've played around with this. I think I was trying to do fault injection using, I I don't remember what I was doing, but it was some dynamically loaded library at like a different point on the art path way back when. So I'm kind of familiar with the mechanics of this. I just wanted to ask, so like in a bigger picture, this talks about building extensions that sort of work everywhere, but the problems being solved here are just the duplication across the spec files, the Debian files, those types of things. You still have to build a different artifact for even like the same extension on the same version of Postgres on two different versions of Ubuntu, right? Am I missing something? Like it is not in fact like an extension that runs everywhere. It is still kind of
No,
the idea
yeah.
that
No, yes, you still have to build against basically the set of attributes, let's call it that, right? That constitute your target, whether that's say architecture, operating system, flavor of it, and all that. So of course, you would still have to build it. It's not yet something you can you can build and just have one binary. I would love to have that. Actually, I've been pondering a lot about this. There's this interesting project that is not really related to plugins, but if you've seen APE and Cosmopolitan libc, they do actually portable executables. So it's kind of a very interesting hack that allows you to run binaries on any operating system even.
yeah, I mean, I
So,
expected that to be kind of pie in the sky. I felt like
right,
asking.
but it's more of a work of art.
Yeah, and then do you know of other like prior art for the RPath? Like I was just on someone on Mastodon the other day was talking about Ruby. I can't remember the library. Maybe it was an SSH one, and they asked about like, oh, do I still have to install this dynamic library? And they said no. Basically, we vendor that now. Whenever you install this, it gets installed like within the Ruby structure. I'm not sure what they're doing there. Maybe it's just a static linking, but I was kind of curious if you have any prior art or other packaging systems that do this kind of like this system is going to manage its own dynamic libraries and use RPath to override the loading of them so we don't use the system ones and don't have to conflict with them. Because I think that's a really good idea. I just was wondering if there's any sort of prior art.
There is an example. There is the Python wheels binaries use RPath. And so pretty much a wheel is a zip file with, there could be your extension. There are all the depending libraries with the path modified so that they can refer to each other into the environments where those gets bundled. So there are several tools. There is a tool chain to obtain this packaging, this vendoring of the system libraries. And there are three actually. There is one for Unix, one for macOS, one for Windows, but they more or less all them achieve the same goal of having libraries where they can find each other into the same directory or into a known directory. So you could take a look at the wheel specification for Python and the implementation. That could be a guideline.
Yeah, that's an excellent reference. Thank you.
The questions?
Yeah, I have one more. Yurii, the build inferencing was really interesting. It was a couple things stood out to me. One thing that was interesting was that you mentioned that you look for the metadata.json file. So that's kind of neat. Just that's kind of acknowledged as kind of a useful thing, and a lot of extensions have it, and we want to make use of it. And like I think everybody knows, part of the background of this whole series of meetings is one of the things we're asking is like, how can we improve? What's like the next generation of meta.json to make all of this better? But I feel, maybe I missed this, but I don't know if I caught like what was your high level takeaway from that whole experience of trying to infer the stuff that wasn't there, or infer enough information to build something if there isn't a meta.json at all? Like, do you feel like it worked? Do you feel like it was successful? Like it was an interesting experiment, but not really viable long term? How many different extensions did you try, and did it work for? did once you put it together, were you ever able to like point it at a brand new extension you'd never seen before and actually have it work? Or like, was it still where like you try a new extension, you have to add a little bit of extra logic to handle that new extension? Like, how did that, like, what's your kind of takeaway
Sure.
from
So
that experience?
my takeaway, so the building part is largely unrelated to meta.json. So that was just primarily the metadata itself being used there. So the build difference worked. I haven't used it in a lot of extensions because I was just trying to look for different cases, basically extensions that exhibit slightly different patterns. Not a whole ton of them yet, unfortunately. I didn't have enough time for that. But I would say that so far, this is more of a case, by case scenario to see, okay, in this particular type of or shape of extension, this is what we need to do. But generally, what I found so far that it works pretty nicely for C extensions. It just picks up, where all this stuff is, downloads all the necessary versions, allows to discover the new versions. So, for example, you don't need to update your the specification for a package. If you have a new release, it will just automatically pick that up from the list of tags. So these were the common, the current findings, and I think overall the direction is promising. Just need to continue digesting the results of that and see how much further this can be taken and how much more benefit it can bring.
Thank you. Thanks.
Any other comments, thoughts?
No more questions for Yurii? Yeah, I think this is an interesting space for some research between like Devram's presentation and talking about how much effort it is to manually maintain all the extensions that are in the Yum repository. And I've been doing some experiments trying to build everything from PGXN, and the success rate is much lower than I'd like. I think that there are some interesting challenges on automatically figuring out how things work versus convincing authors to specify in advance.
Yep, or taking on that maintenance, kind of like what, a spec file maintainer or like a Debian package maintainer is sort of doing to some extent.
Yeah, precisely.
Yeah. I'm going to switch back over to, oops, that's not what I wanted. All right. Thanks, Yurii, for that. I wanted to remind everyone that we have our final mini summit before PGConf on May 15th. That's 2 weeks from today at noon Eastern or 4 p.m. UTC. We're going to talk about organizing the topics for the summit itself. I posted a long list of stuff that I've extracted from my own brain and lots more topics that I've learned in these presentations in the Slack. So please join the community Slack to participate there. And the idea is to winnow down the list to a reasonable size. We already are full at the conference with about 45 attendees. And we can maybe have a few more with standing room and maybe some hallway track stuff. So we'll figure that out, but it's a pretty good size. So I think we'll be able to take on a good 6 or maybe 8 topics. So we want to try to winnow it down to that. So I'm going to kind of go over them all and we'll talk about them and try to make some decisions in advance. So when we get there, we don't have to spend the first hour figuring out what we want to do. We can just dive in. And that's it. Thank you everybody for coming. I really appreciate it. Whoops, that's what I meant to do. And we'll see you next time.